Hello YouTube students, my name is Vincent and today I want to take a look at multiplying complex numbers. In particular, I want to look at the examples 3 minus 2i times 7 plus 6i and also negative 2 plus 6i times 3 plus 4i. Now before we get started, let's take a look at what we're going to need to solve this problem. We need the fact that I squared is equal to negative 1. This is just a fundamental definition of I, which gets the complex numbers started. We also need to be able to multiply binomials. In each of these examples, it's important that we know how to utilize the distributive property, or as most teachers will show it, the FOILing process. Also, we need to be able to add integers. We need comfortability with adding negative numbers and positive numbers, or subtracting negatives from positives. That's going to be important to solve these problems. And finally, when we get all of our work done, our answer needs to be in the form of a plus bi, where we have some real number a and some real number b in each of these places. That's just the preferred form for writing a complex number. So now let's go ahead and get started. We'll start with the first problem here. And we have 3 minus 2i times 7 plus 6i. So now we get started by multiplying these two binomials together. We're going to multiply 3 times 7. This is 21. Now next we could do 3 times, a positive 3 times a positive 6i. We're really just multiplying 3 times 6, and we have 18. So 18i, since this is a 6i. And now we have a negative 2i times a positive 7. This is a negative 14i. And now finally we have a negative 2i and a positive 6i. Well, a positive and a negative is going to multiply to a negative number. And now we have 2 times 6 is 12. And we have I times I is I squared. And now this is the part of the problem where it's important to consider this fact here. So what we could do first is we could combine these like terms. So we have 21 plus, and now we combine these like terms. We have an 18i and a minus 14i. This is going to be a positive 4i. And now instead of minus 12i squared, we're going to have minus 12, and we're going to substitute for I squared. I squared is equal to minus 1. So now the next line will say 21 plus 4i minus 12 times negative 1 is negative 12. But now what do we have here? We have this, we're subtracting a negative number. So this operation is going to turn to addition. So now in the next line, we could go ahead and add 21 and 12, since they're both the real part of this number here. So we have 21 plus 12. This is going to give us 33. So we have 33 plus 4i. And notice how our answer is in the form a plus bi, where the real number a in this case would be 33, and the real number b in this case would be 4. So our answer for this problem is 33 plus 4i. So now let's go ahead and take a look at the next example. We have negative 2 plus 6i times 3 plus 4i. So we'll go ahead and write this down. Times 3 plus 4i. Okay. So now we're going to do the same thing for this problem. We have negative 2 times a positive 3. This is a negative 6. We have negative 2 times a positive 4i. This is going to be a negative 8i. Now we have a positive 6i times a positive 3. This is going to be a positive 18i. And next we have a positive 6i times a positive 4i. Well, 6 times 4 gives us 24. I times I gives us I squared. And now once again we need to substitute for this I squared. And we can also in the next line combine like terms. We can combine the I terms together. So now we have negative 6, and now a minus 8i and a plus 18i. This is a lot like 18i minus 8i. This is going to be a positive 10i plus 24 times I squared, but instead of I squared, let's call this negative 1. So now we have negative 6 plus 10i, and now 24 times a negative 1. This gives us a negative 24. So now in the last line we need to combine negative 6 and negative 24. Those two will add together and give us negative 30. So we have negative 30 plus 10i. And notice how our answer is in the form a plus bi, where in this case our real number a is negative 30, and our real number b is a positive 10. And this is our final answer. Okay, well this is going to conclude the two problems as well as this video. Thank you all for watching, and I hope that it was helpful.